Hello everybody, my name is Marquand Bowman and this is my content-based image retrieval presentation for my digital imaging processing class. The purpose of this project was to take an image from a database and compare it to the other images in that same database to find the most similar images using a query by example content-based image retrieval system. With a content-based image retrieval system, images are represented by visual features. These features are things like color, texture, and shape. To successfully use the CBIR, these features are extracted and compared to each other. A filter is used to remove noise from images. There are three types of filters: average, Gaussian, and median. An average filter is a method of smoothing images by reducing the intensity variation between neighboring pixels. The Gaussian filter is a linear filter used to blur images and to reduce noise. And a median filter is a non-linear digital filtering technique that also is used to help remove noise from an image. When using morphological filters, you do a shrinking process by removing outer pixels first, and then you regrow the image by adding outer pixels to the image. Now, what is a CBIR, you might ask? CBIR is short for Content-Based Image Retrieval. It's a way to query images from an image database. It uses visual features such as color, texture, and shape to sort through images and return images that are similar to the selected image. Here we have our project outline. Our project was split into 5 smaller projects to make it easier for us to complete. The first step was to build a 6-bit color-coded histogram and store those into a database. The second step was using Euclidean distance to measure distance between our selected image and the images in the database. Step 3 was the implementation of a QBE-based CBIR framework. For those of you who don't know, a QBE is a query by example based content-based image retrieval framework. Step 4 was to rank our target images and store those values. And step 5 was to display the most similar images. So in this step, we had to build a 6-bit color-coded histogram using the histogram counts for each image in our dataset. These counts were then stored into a matrix in our image database. And this is a screenshot of the function that we use to get these images, these histogram counts. In the second step, we had to use the function below to measure the distance between the query/target image and the other images in the database. We used a getDistance function that compares the query image and the images in the database to measure the distance between the two. Function D equals getDistance, P and Q are your two values. D equals the square root of the sum of Q minus P to the second power. Instead of using a 1 or 2 dimensional space formula, we had to use Euclidean distance, which is the distance between 2 points, P and Q, in the given space. In step 3, we had to implement a query by example CBIR framework that would let the user select a query image. This is what we use below. We have our import path that takes information from the data in the import folders, and we use those to get the image that we want to select. In step 4, we had to rank our images. So images are ranked in ascending order based off of the distance that we calculated in step 2 from the query image. And then we rank those, and then these images are ranked in ascending order, and rankings and measurements are then stored in the matrix with each row representing a different value. And this is how they were ranked. This is the code for ranking those measurements. Our last step was to display the results. So we had to select a target image. which was our query / target image, and then we ranked the top 20 images that were similar to our query or target image. And this is just an example. Here we will now go through a tutorial of our source code and our final project. So here in this current folder, you see it has all the different files that we use to help with this project. Get distance, get his count, RGB26, CC fast, CBIRs, create DB, small data, distances.met, sorted distances.met. These are all the different files that go into this project. In this workspace area, you have matrices. In this one, you just have a bunch of different values that was calculated from one of our programs. In D, you have all the distances that was calculated with the distance function. As you can see, there's only one column of values. That's because we only need one value per image. If you go down, each row has a different value ranging from image 1 all the way down to image 100. Our database has 100 images in it, so you have 100 different values. I will now go through and show you the actual program running using the CBIR2 function. If I hit run, it will prompt me to select an image. So for our first example, I'll use image 54. As you can see, it shows our original image up here in the corner. And then it shows 20 different images that are similar to it. These first couple images are almost identical to this image here. And then you have some that slightly vary, and then some that may be completely different, like this one. That's because, although these are completely different, they share the same histogram counts. And when calculating the distance, they had distances that were relatively close to each other. So they got ranked in the top 20 when we were ranking them. I'll show you a different example. Let's take image 483, for example. Now you can see there are some images that are very similar, like these two. Some that are not quite the same, but share some resemblance colors. And then you have some that are completely different. But again, they ranked in the top 20 due to their distance based off of their histogram counts. And I'll now show you one more example. Let's take image 1310. Again, you can see this is the original image up here in the corner, and then these first few images, these first 10 images are almost identical to this image here, but these last 10 are completely different, but they share colors, they might share the same textures, and the visual features of these images match up closely to this original image that we selected, our query image. So when we're doing the get histogram counts and the distance rankings, they ranked in the top 20. Now this is going to be the end of the tutorial. I'll now briefly talk about the most difficult part of the project for me. For me, the most difficult part of this project was getting everything to run together. When we got to the end of this project, trying to run this thing and have it prompt us to select an image, and then display the top 20 ranked images, I kept getting a lot of bugs, little bugs, but bugs that I overlooked, and they weren't really prominent until it got time to put this whole thing together, because it was taking me back to other functions that I created that had problems in it that I may have missed in the original making of those functions. So that was the most difficult part. But it was a lot of tedious work just going back through and fixing all the different mistakes that I made, syntax errors or naming errors, not naming things correctly, that caused things to crash and have these little bugs that prevented my program from running originally. But that's the end of our presentation. Thank you. Please feel free to reach out if you have any questions or comments. Thank you.